Welcome back, everybody, for our fifth session of Careers Week and our third day. Very excited to be here again. Today we have AJ Ibrahim, who is from MathWorks as an engineer, and he'll be talking about navigating the future, so career pathways in AI, robotics, and computational science. If you have any questions along the way, do feel free to add them in the chat. But for now, I'm going to hand over to you, AJ, and get started. Thank you.
Awesome. Hi, everyone. So, like Shireen said, my name is AJ Ibrahim, and I'm a software engineer at MathWorks. So today I'm going to just sort of go through what MathWorks is, what career paths in AI kind of look like, and what sort of like day-to-day looks like. Okay. So I've been at MathWorks for 5 years, and I've primarily been working on a product called the Deep Learning Toolbox. And at this point, you're probably wondering, what is the Deep Learning Toolbox? Or what is this? So it's basically an AI framework. It helps you train neural networks. It does a lot more stuff, but I would just sort of cherry pick some examples that happened recently. The first one is using AI to generate images. So I think some research organizations found some old images and there were bits cut out from it. And they wanted to imagine what those bits look like. They sort of use the deep learning toolbox to generate, little patches of what that bit could look like. Another example, which I imagine was a fun university project, is on optical character recognition. So here, a professor and the students, they used the deep learning toolbox to convert whiteboard sketches into a program, which I imagine must have been fun to develop. And the last example, which probably is a bit more relatable to everyone, is on building better engines and airplanes. As we all know, flights are getting cheaper. Well, I guess it depends on where you're traveling to. But generally over the years, flights are cheaper just because the engines are more fuel efficient. One of the ways by which engineers make the engines more fuel efficient is by running loads of simulations, trying out different configurations for the engines. And the simulations are really expensive to run. One of the ways by which they cut down time on the simulations is by just using AI models to simulate what the engines would look like and how they'll perform. So hopefully that sort of gives a brief overview of like the deep learning toolbox that I've been working on. And what I can do now is sort of talk through my background. I can sort of start from university and come all the way to the MathWorks. Okay, so my background is actually in software engineering and not your traditional mechanical or electrical engineering. So I started off at Brighton University, which I I love Brighton. So, studying there was honestly delightful. I did a software engineering degree at Brighton University. And afterwards, I moved to Southampton University. And there I also did, the course titled Artificial Intelligence, but I mostly focused on computer vision while I was there.
Sorry, AJ, to interrupt. A few people are saying they can't see your screen. Can people just double check? Can I just double check people in the chat? Can you say if you can see his screen? Okay. Can you stop sharing and then share again? Let's try that. I can see your screen, so
okay.
I'm not entirely sure why. Okay, everyone's saying they can't see anything.
Oh, okay. I'll try sharing again. I can't see an error message here saying please close all browsers and rejoin the meeting. Oh dear.
Okay, no problem.
Let me try sharing one more time, and if that doesn't work, then I might have to close the browser.
No problem. Okay, I can see your screen now. Can anybody else see AJ's screen? Yes, we're getting yeses. Fantastic. Yeah, feel free to continue. Thank you very much.
Oh, that's perfect. Okay. Sorry about that.
No problem.
Probably if anyone has any questions, I'm more than happy to go back if they want him to clarify anything. But really, I was just talking about my university background. I talked about my undergrad and now my master's. Okay, so I did do quite a lot of internships while I was at university, and I also did work part-time. So I started off, I think this was probably in 2015, 2014, working at AstraZeneca. There, I mostly focused on clinical trial software. And in my second year, when I was working part-time at AstraZeneca and also doing my final year at university, that was kind of where I sort of started getting into the trenches of machine learning. And there I mostly sort of focused on drug discovery. And I did do my final year thesis on drug discovery and machine learning. And I remember I was so happy with the project because at the time I didn't have any background in chemistry, but it was quite exciting to see how someone with a pure computing background could get into the sort of chemical drug discovery and also biology domain and contribute in a way. So in the summer after my undergrad, I spent the summer at Microsoft Research, and there I kind of focused on another deep learning framework called AmpNet. So at the time in 2017, the industry was beginning to converge on PyTorch and TensorFlow as the go-to deep learning frameworks. But at the time, I was working on AmpNet that summer. So I think after Microsoft, I went to the university to do my master's degree. And there I was also working part-time for a local company called Motion Robotics. And I mostly focused on computer vision. I think then I discovered how much I love computer vision. This video you're seeing here is an example of one of the projects I worked on, which is basically a landing zone recognition for a drone. So there we just drove a drone through the common, and we just sort of showed that we could designate a landing zone, and the drone would recognize it as it was flying through. So that was really interesting to work on. And really after Southampton, I kind of joined the MathWorks. And like I said, I mostly focused on the deep learning toolbox. But at the MathWorks, we don't just have the deep learning toolbox. We have a lot of other products. For someone who isn't familiar with the MathWorks, because I know personally, like outside of the engineering domain, many people, probably encounter MATLAB in university. And I can sort of give some examples of MATLAB and Simulink. So in a nutshell, MATLAB is a programming platform, and Simulink is a block diagram platform. And I'll show concrete examples of what I mean. These are just sort of high-level overview of these systems. So for example, with MATLAB, you could do quite a lot of detailed data analysis. There's powerful functions you could call to help you crunch through large numbers of data. You could also do quite a lot of visualizations. You can do custom graphics. So these are examples that I chose. Don't really sell the product, but you can do a lot of really cool data analysis work in MATLAB. And there's a whole lot more which I'm not really talking about. I've just sort of set it on data analysis and graphics, but there's quite a lot of features that our customers are able to build with the product. Simulink is also really popular amongst engineers. I always tell my parents that, because when my dad asks, what is it that you do? And, I struggle to describe it to him. I always tell him that, like, a lot of engineers building drones, cars, airplanes, they use Simulink a lot. And, earlier when I said Simulink was a block diagram environment, this is kind of what I mean. Like here, you just drag and drop blocks as an engineer, you connect them up, you hit play, you can run a simulation of how the drone is going to behave and run tests. You can test the drone there too. One of the really powerful features of Simulink is that when you're done testing and simulating, you hit a button. So the button is invisible here, and it generates C++ code for you. And as an engineer, that is a massive time saver because you can do everything in one platform. But this talk is on AI. So I'm just I'm going to go through how MATLAB and Simulink have been used in the AI field now. So I'll go through some examples. The first one, which I always love telling my dad to, is about the Mars rover. You know, everyone, I remember the time when it was launched to Mars. I didn't know too much about how the technologies were being used behind the scenes. But when I joined, I found out that, a huge part of it was done using MATLAB and Simulink. And here I've got a screenshot of, a tool called Moxie, which basically was used to generate oxygen on Mars. MATLAB was used for quite a lot of the back end, testing and simulation. Another example from the computational field is on studying cheetahs and how they run. So a research university, analyzed videos of cheetahs, and they use, quite a different amount of toolboxes that we provide. The deep learning toolbox that I work with was one of them, but they also used other toolboxes to sort of learn more about how cheetahs run. And the last example I can sort of give is on Schneider Electric. So really, systems like this are always in the background in buildings that we, stay in, but we never notice them. And here they're really applying embedded AI to sort of perform predictive maintenance, knowing when these parts are going to break, and just getting on top of it before it happens. Okay, so there's been a lot of background talk in this presentation, and I can probably go into details now on how this applies to you and how you can get involved in AI. But I kind of want to motivate and set the scene by telling you that there is space in the AI industry. And I put AI in quotes because, I didn't start off this presentation by defining AI, because AI means everything from, technology that was developed 30 years ago is still called AI and being used today. Technology that was developed recently, like the image and video generators, are also AI. So really, AI is broad, it's all around us, and it's only going to get more and more involved in our lives. And we probably encounter these devices on a daily basis. But it's not perfect. We all know that. But it really kind of hits home really when you realize that, oh wait, this system is built using AI. I'm a big fan of AI, but really it doesn't work well like it should. Facial recognition is a really common example. And this cuts across race, gender, and different other dimensions. And everyone just realizes that way the technology isn't perfect yet. Another example is in credit scoring. Sadly, many financial institutions still use, outdated AI models that are prone to biases, just because, it helps them get the job done a lot faster. And the last example, which is probably more relevant to everyone here, is ChatGPT LLMs. They're mostly trained on English, but the reality is that only a small, well, not small, I'm sure everyone speaks English as either their first or second language, but in the context of the wide world, there's so many languages out there that it is bizarre why English is a dominant language used to train these systems. So really what I'm trying to say is that, you should get involved in AI, and the more you get involved in it, the better it is for everyone, really, because there's quite a lot that can be done still in the area. Okay, so I can talk about how this relates to you, and before I sort of talk about how you can get involved in AI, I'm going to talk about it from the perspective of engineered systems. So obviously part of the reasons why I'm going on about engineered systems, robotics, is because at MathWorks, the company's goal, the company's motto is accelerating the pace of engineering and science. And what this means is that as a company, we just believe in empowering scientists with tools. And really what we've noticed over the last couple of years is that many of the engineers and scientists we talk to, they just want AI tools. And they are they are telling us that we want something to help us do something, and it usually involves AI. And the reality is that, you look back 30 years ago, back then, many of the engineering systems that were being used were handcrafted. Some engineers going to go in there, they probably have a background in mechanical, or electrical, and they're going to go in there, write all the tools, everything's all written by hand, and that was fine and that was great, But now people have new requirements; they want more done, and companies are beginning to realize that okay, the next frontier in what we can do is to apply AI in it. So I'm going to pause on this slide. And if there's any takeaway, I mean, if you forget everything I've said, the only thing you should remember from this presentation is that AI is becoming the secret ingredient for a lot of engineered systems. So again, this is really important. And I might sort of come back to it every now and then. So for someone who wonders what I mean by engineered systems, because this is a talk on AI, robotics, and computational science, and sometimes we refer to it as engineered systems, I would sort of give some examples. The first two, the ISS and the rocket, are probably more familiar with everyone. Like everyone sees that and say, oh yeah, obviously, yeah, that's an engineered system. But when I point to Tower Bridge and say Tower Bridge is also an engineered system, sometimes people go, huh? Like Tower Bridge, isn't it just a bridge? We're talking about engineered systems here, but actually it's a perfect example of an engineered system. It does blend architecture, mechanical, and computers together. But probably a bit more relatable are these kind of systems. Everyone probably has some form of this at home. And, these three things aren't new. Like a vacuum has existed for more than 20 years. How is a vacuum, made in 2025 better than a vacuum that was made in, 1970? And a common answer that you probably find is AI. And I'll go through some examples. Let's take the next thermostat. Right. Boilers have existed in this country for God knows how long, in some form or the other. So why is the boiler and the thermostat you have in your house better than the one you had, or someone else had 20, 30 years ago, right? And a big reason you would hear is AI, or specifically in this case, machine learning. You can punch in, you can program your thermostat, and over time it's going to learn your patterns and adapt and just make life more comfortable. And that's only possible because now you can just sort of program the systems to be more smarter. Another example, I definitely wanted to keep this example there because this applies to me a lot. I've got one of the Dyson vacuums, and when I'm vacuuming at home, I just love how when I transition from one floor to another, the suction power goes up without having to press any button, and that's another example of AI, making all the difference and making a system that was built now and 20 years ago much better, just because as a consumer or as a customer, I'm just able to do a lot more. Okay, so the final example is on lane keep assist. And I'll come back to the example when I'm talking, when I'm going through some details about this kind of systems. But obviously, briefly, lane keep assist, just helps your car stay in the lane when you're driving. This is really handy for those long road trips that like 3 hours, and you don't want to get tired, but you just need the car and just driving, and it makes life a lot easier. But like I said, I'm trying to relate this to you, sort of show you how you can get involved. And I kind of hope I've set the scene by showing you interesting examples of these kind of systems. And we've probably seen this image, or rather, 10 years ago, all the headlines were about how software is eating the world. Software is becoming the new mega trend, and everything is all software, computerized, and that is the big thing. Now this year, if you've seen all the TV ads, and especially on YouTube, got so many YouTube ads on AI, pretty much everyone is telling you now that AI is eating software. I don't know what's going to come after AI, but it's an interesting pattern to show that AI is becoming the driving force for software, which previously was the driving force for a lot of world systems. So again, just to remind you again that this is sort of the main takeaway from this presentation, which is that AI is becoming the secret ingredients for a lot of the systems. So I'm going to go back to the Linkkeep example that I talked briefly earlier about. A mechanical engineer at this company, probably, I don't know, 20 years ago, right? If they're using Simulink to design a system like this. Because obviously, so like I said, Simulink is a block diagram. As an engineer, you've done, I don't know, your bachelor's in school, you get taught the theory, but in the real world, you are just going to use a system like Simulink. And, rather than writing, I don't know what example, but, rather than writing everything from scratch, you just drag and drop a block and you connect them up. And that's kind of what Simulink lets engineers do. And what we've realized, okay, let me stop this video and sort of show this one. I don't want you to look at the details. This is just an illustration. But typically an engineer at an automotive company would probably drop a system like this. So again, don't focus too much on what each block is doing, but just know that this is representative of what engineers would typically do. And yeah, so 10 years ago, this was probably what they would do. Many of these blocks will be using handcrafted logic. But what we're hearing from customers recently is that they just want to replace many of them with AI. And many of the recent solutions we're developing are just replacing these blocks with AI. And so at this point, I've gone on and on about AI and how it's the most important thing for robotics, computational science, aka engineered systems. And what I'm saying now is that these AI systems, right, how to build them, how to use them, they are democratized. And what I mean by that is compared to other fields like chemistry, medical, you have to go through rigorous training to become certified in using these tools. But right now, we are living in an amazing time whereby the resources you need to get better at AI, learn how to use them, they're readily available. Right, you could go to school, you could go through courses, you could do a lot of stuff. Like you could go pick up the right books, and really you've been in a position whereby you can build AI systems. And the moment you start building AI systems, right? And again, this is very, very broad. It ranges from machine learning to deep learning to different kinds of intelligent systems. But the moment you start building these kind of systems, you would then begin to find yourself being able to transition to larger companies, to like engineering firms. Like 20 years ago, right? These firms weren't advertising roles for machine learning or data scientists because they just didn't need to. They were getting on just fine with their engineers, that they hired, the traditional engineers. But nowadays, you look up any large engineering firm, and you're probably going to find a role for a machine learning engineer or a research scientist, a data scientist. You're going to find these kind of roles being opened up now in these companies, and that's just because AI is becoming the new thing. And one of the ways by which you can open up the pool of companies that you can apply to is by just learning more about artificial intelligence. Because the moment you learn more about PyTorch, about TensorFlow, scikit-learn, and even MATLAB too, you just find out that there's a lot more places that you can apply to. So as a reminder again, it is becoming a secret ingredient. And it is very, very easy to learn. Oh, not easy to learn, but like it's easy in the sense that you can, there's a well followed path that you can take in the field. So I'm just going to sort of, obviously I'm getting towards the end of my presentation now. I'm just going to talk about some resources that you can use to get better at AI. Obviously, the first one is online courses. So I like to think of online courses as, the cutting edge version of the technology, and the textbook as sort of the historical version. Both of them are needed, and online courses are really good at sort of giving you that cutting edge knowledge that a textbook just can't give you. Kaggle is also something that I've seen everyone using. When I was in university, used Kaggle. Now that I'm in industry, still using Kaggle. It's a great sort of data set and just practice problems. I'll definitely encourage anyone trying to, use AI more to just sort of get more familiar with Kaggle, play around with data sets there, build simple models to perform certain things. It's just an overall great resource to get more familiar with. Another example or another way to sort of get better at AI is to just write about it. And writing about it takes you from student to teacher, because you kind of have to know how it works deeply to be able to talk to it. So to be able to talk to someone else and teach them how to use it. So writing about, and I remember when I started writing, my main worry was that I don't know anything about this topic. I've only just learned it. I've read one chapter of a book, and I'm going to go out there and start teaching, people how to do it. There's probably a professor out there going on Google looking for important resources and going to stumble up on my blog. And I'm just saying to you that it is worth it. Like, it is definitely good for you and for other people too. I can't count the number of blogs I've come across that helped me, and it just, helps you. And it's also a way to sort of, give back to the community. The last resource I'll give is personal projects. I think getting hands-on experience is always great. Like, I would always recommend you get hands-on experience. Like, this video you're seeing now is a video that I took when I was in Southampton. I think this was probably 2017 or 2018. I can't remember. But I know at the time I was learning about object detectors. And, I just said, you know what, okay, I'm on my way back home, while I was driving, just, took my phone, put it there, and just recorded a video of me driving through the city center. When I got home, I ran that through a YOLO V1 object detector, just to sort of learn more about it, like just getting that real hands-on experience, because nothing beats that. And I should probably mention that this is also great for one CV, because, you go to a job application, you're talking about, oh, do you know this? Do you know that? It usually helps when you have something that you can point to and say, hey, I recently spent, X amount of time writing an object detector. And that just helps the conversation flow. You're able to talk to, potential employers easily, because they know that you know what you're talking about. So obviously there's different tracks you could go for personal projects. On the right-hand side, I kind of have, an applied project. This is very, very applied. I'm not showing, the details of how I'm not going through, what multiplication is, or how addition works. I'm just sort of showing how, object detectors work. But on the left-hand side, you could also go theoretical. It really depends on what message you're trying to convey, and really what you find interesting and what you're trying to learn more about. So either approach is right, but the most important thing is just to get your hands, busy, and get your hands working on projects. They don't have to be, the next invention or the next groundbreaking project. Feel free to replicate existing projects, but the most important thing is just, getting getting involved in these kind of things. Okay, so we're getting towards the end. And I really hope that, I've tried my best to illustrate, different career paths, talk about myself and what we do at MathWorks, and also what we've seen customers ask for in this industry. So I'll just quickly sort of end by talking about opportunities, in case anyone is interested. So because of the nature of the customers that we serve, like I said, many of them really are asking for AI. The range of projects that we get interns and graduates to work on is quite broad. It really varies from a lot of stuff. We mostly hire, people with a computer science or engineering background. But this picture actually isn't too accurate because we have a lot of, UX professionals. We have a lot of, other industries here. So do, reach out if this is something of interest. The internship program is one that I quite like, actually involved in. We do hire interns, at different points throughout the year. But the internship program is quite great for just trying it out, seeing if it's something of interest. The EDG program, we call it EDG, but it's really just aimed at graduates. It's quite a natural transition. Many people find it from university into a working environment. And yeah, so the EDG really, the main focus there is on mentoring and teaching new grads on how to build a successful career at NatWest. So the key message of the internship and the graduate program is that it really is a big way to make a huge impact. MathWorks is a supplier for other industries, and by making the tools better, you're really sort of passing that forward and helping other industries, providing them with good tools so that they too can make good products. And the graduate programs are quite flexible. While you're here, you get to see different aspects of the company, and you get to see different ones that you want to get involved in. It really is great if you're just fresh out of university. It's a good transition into a professional environment. Training and support is a big part of it. And the one thing you would find is that for someone like me with a non-engineering background, my encounter with MATLAB was in university. And similar to Charlene, so we encountered MATLAB at university, and that was our first encounter. But obviously now here I am working with it every day, and that we find is quite reflective of what most people encounter. Some people have never encountered MATLAB before. So what I'm trying to say is that shouldn't deter you from applying. And obviously, and vacancies are open all year round. The company does have branches across Europe, and so it's not just restricted to the UK alone. So there is a QR code where you can register your interest, and I think so you could click the link, but sadly I just realized that I am presenting and you wouldn't be able to click the link, but you can always scan the QR code and that will take you to the page. And yeah, that's mostly it from me. And like I said, if there's any takeaway that you would take from this talk, is that AI is becoming the secret ingredients for a lot of these systems.
Thank you, AJ. That was really insightful. I've seen loads of people be like, oh my God, there's actually things that I could be trying to do and get involved in. We do have a couple of questions that have come in since you started. The first one, we had Amina who asked if we could go back to the opportunities slide and just see that list of opportunities that you have available at MathWorks.
This one?
That one, yes, I think it was that one. I will also take a screenshot of it so that I can include it in the follow-up email that we send out. Whilst we're here, we did have a question that came in from Lydia. So Lydia was asking, do you know what is the technical debt, or how biases can affect or cause issues with facial recognition, particularly pertaining to darker hues as well?
Oh, absolutely. That's a good one, actually. I'm trying to see if I can find that GIF I had a while back. Yeah. But what it's a complex issue, so see, I'm not going to try and solve it in one go. But what personally I have found is that, say for example, I'm trying to build a facial recognition system myself. If I need data, because these systems all run on data, my go-to is always Kaggle. And if you're a company, you most likely would go out and get your own data. And you're getting the data from the internet. And the internet, sadly, is biased, heavily biased. But as a company, it is very, very expensive to go out into the real world to get data. It's a lot cheaper to just scrape the internet. And if you're going to scrape the internet, well, you're going to get biased data. And as a result, when you deploy it in the real world, you know, it's just not going to perform as expected. But luckily for most companies or their target users, you know, it would work for 80% of the consumers. And 80% is good enough for a demo, for getting, you know, a lot of milestones hit. But it does mean that some people would be affected by this.
That makes sense. Do you know of anywhere that people could go for data sets that do contain more Black faces or people of color?
I think there have been efforts to create more sort of you know, diverse data sets, but I'm not aware of any sort of particular one. But I know that now the industry is beginning to sort of acknowledge these gaps and carefully curate data sets that work for, you know, different skin tones and even just gender, because sadly a lot of you know, for facial recognition, you know, some of them might be biased towards certain genders, you know. So, so yeah, so there has been more. Sorry, people are thoughtfully crafting the data sets now.
Yeah, and I guess there's loads of apps coming out now where you can take a picture and upload it, and then it does some things to it. And I'm sure they're using a lot of that data as well to train new models, and there's going to be other data sets available. So when we're uploading all of our data, I guess it's just remembering that that data is then being used as well.
Exactly.
Yeah. One thing that I found really useful, and I think a lot of people found useful, was the kind of knowledge that AI is more than ChatGPT. And there's so much conversation that happens around with ChatGPT or with large language models. And there's all these apps out there that can now write code. So there's no space for developers anymore. We're all going to lose ourselves. There's nothing to do. The great thing I think that you covered was the fact that there is still space for developers. And it's really having that understanding of where we belong within that. Are you able to elaborate a bit more on what people can do? So if you've been learning a language or come off a boot camp, something like that, what can people do to actually be involved within AI and what's happening in that space?
Oh, absolutely. I'm trying to think of an example. So obviously, everyone sort of views, you know, like you've learned a new language, you know, you'd probably want to go work for a software company, but it's not just a software company that you can go to, you know. Let me try and see if I can find sort of like a simple example. I don't know if I've got, yeah, maybe these ones might be better. Like the reality is that if you're in a big company, you're not going to be building the entire thing yourself. You're going to be an expert in one thing. This system that I've got here kind of illustrates in larger companies, each rectangle here will be handled by teams that consist of more than 100 people. So you're never going to be the only one building the entire thing from scratch. And you know, if you've learned, say for example, Python or scikit-learn, you know, whatever this system is doing, you'll probably be working on, you know, just one rectangle of it. And you know, in whether it's an engineering firm or even a traditional software company, your bit will be targeted towards what you can do. So really, it's a case of finding the right fit. You know, I know how to train, you know, machine learning models to perform text classification or, you know, something really simple, small, and targeted. And what you'd find is that there's quite a lot of companies whereby they need someone who can do that small targeted thing. And it's really just skill searching, you know, finding, you know, where the fit is.
Yeah. So it's kind of about maybe doing a bit of, rather than being a generalist, I suppose, sometimes it can be quite useful to have really specialist knowledge in a particular area that's in demand, and that could be Python development at the moment, because a lot of people are moving into or making sure they're updating their systems with AI elements or whatever. So actually knowing a particular language well could serve people quite well to then be able to get into the industry and be a part of it as well. That makes
Exactly.
yeah. One other thing that you mentioned, which was really useful, I really enjoyed watching the video that you recorded and then using that to do object recognition. So I did a similar thing once with using a Kaggle data set, did some object recognition using with an iOS, so building an iOS app doing that. And that was quite a fun little afternoon project because I like to build random things in the afternoon, apparently, at the weekend. But I think for people who are here, a lot of people, we always recommend, build projects in your spare time, and that can be really useful for your CV. And you've just said the same. It'd be really good to know, like a really tangible way. If somebody wanted to go away and do this, what would the steps be? Is it like, go outside, maybe record a video, take some pictures, and then write code in X and then do something? Well, how can somebody actually get involved if they don't have that skill yet or they don't have the experience yet?
Absolutely. And one thing I've always noticed is that getting started feels very, very daunting. But the reality is that once you get the ball rolling, it's actually a lot more smoother than one realizes. And one thing that always helps to differentiate is trying data that you've kind of, obviously it's a bit hard to go out and curate your own data, but it really just changes what you can talk about. You're not using a data set that everyone else has access to. It's your own data that you've gotten, and it's a lot more interesting. It catches people's attention a lot more, and really, especially now with ChatGPT, like that burden of getting started is a lot lower now because you can get started a lot quicker, and just pick one problem. Typically, it's whatever you find interesting, whatever you wouldn't get bored with, and just try using ChatGPT, try your own data, and just really just add it to your CV, put it on GitHub, and just add links to it. I found this out recently, but a lot of recruiters do click on links in people's CVs, and just put in your CV, they'll click on it, they'll see a nice video, like, oh, this looks interesting. Okay, let's talk about it. And yeah.
Okay, so maybe somebody could, so if they did get a data set from Kaggle or something like that, so you get a data set from Kaggle, maybe with cars in it, I'm just coming up with a random thing, and then you use that to train a model, so you can look up in ChatGPT using Python and a data set from Kaggle, how could I train a model to understand and recognize vehicles, maybe, and then go out and take some pictures of some cars and maybe some buses or a video, so on, and then look up again, how could I use Python to recognize what we can see? And then you've got a full path there as to how to actually train a model and then use that training to build an AI piece of software.
Yeah, pretty much. And the reality is that you're not going to be the only one trying to do it.
Mm-hmm.
So by just even searching on Google, you'd find pieces of the puzzle. I like the way you broke it down. And for each bit, you can just Google it, and you probably find that someone else has done it. I think for some of these things I did, I just wrote a blog about it. And and trust me, my blog is based on other people's blogs. So I read other people's blogs, write my own blog, and I don't blog anymore. But at the time, that was pretty much the process. And that's also the same with this. You would find someone else's work, copy that. Copying is great because it makes you better.
Yes, we do love to copy other people's work. I think that's what we do as developers, is just copy what other people do.
Pretty much how we get better.
We did have a question about your blogs. So somebody asked how they can access them or how they can view them. Can we get a link that we can then share with people as well?
Sadly, the blog is more of a relic of the past. I haven't maintained it, and many of the articles are sadly not
all
great.
these articles are just gone now, and we can never read them.
sadly.
At least we know they existed. We know they were there.
Exactly. I struggled to find screenshots of it, but I sort of stopped logging from 2019. So
Okay,
it feels like ages ago now.
fair enough. So we did have another question from Marie, and Marie's asked, is there another way to break into the AI field, sorry, for someone who does not have a technical background? So not everybody's come from engineering backgrounds or computer science. How else can people get involved?
Oh, absolutely, and that's a good one. And honestly, even there's always space for whatever skills one brings. You know, I know someone who's transitioned from marketing into analytics, and from analytics into their programming in Python, and they love Python programming more, and they got a job as a traditional software engineer, and then they got interested in AI. So it's never a linear jump from whatever field you're in to where you want to be. Sometimes it's kind of like a zigzag whereby you're trying out different things, moving around, eventually till you get to where you're trying to be. So it really depends on where you are right now, uh, what the next small step you can take is, because it might not be practical, to go from marketing to chemistry. Most people will be like, whoa, 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 I need a chemical expert to do this job. I don't need a marketer. But the reality is that as you slowly begin to sort of, shift careers, you would eventually get to the target destination. It's always going to be personalized, but that's pretty much what I've realized from speaking to a few people.
I guess as well, the field is almost, it's not as though AI is a role. AI is like, it's like saying, how can you be in IT, if you know what I mean? There's so many things you could be doing within the space
Exactly.
that it's probably worth identifying what there is, what aligns with how you enjoy working, that sort of thing, and then figuring out the steps to get there. So as you mentioned, it's not really linear, is it? There's so many different ways and so many different steps you could take.
Exactly.
Which actually leads really well on to the question that Liz put in the chat, which was, could you kindly give us examples of roles in regards to any organization, any specialization, sorry. So like some defined roles you have seen being advertised within the AI space that people could look up and have a go applying for.
Absolutely. So I think there's typically three buckets. The first one is more scientist-based roles. So this would be like your data scientist, machine learning scientist, deep learning scientists, and whatever prefix and sciences you want to add to it. And these roles tend to be more theoretical. They kind of want you to publish papers. I've done deep research in those fields. And there's a suite in between, which is more engineering based. This for these kind of roles, they don't want someone who spent, I don't know, 10 years at uni learning calculus, and they don't want that. You would terrible at being an engineer. They kind of want someone who knows how to solve problems. And typically these engineers are people who have a more traditional Python or programming background, and they know how to apply techniques. Basically they get given something by a scientist, they treat it like a black box and they just apply it. A really good example is the object detection, right? As an engineer, you don't need to know the details of the algorithm. You just need to know how to, really build a system around it. Kind of like what you did over the weekend, whereby you built an iOS app. Like that's kind of what a lot of companies want, in the sense that the theoretical side has been solved. We need someone who can take the theory and turn it into a working piece of software. And the third bucket is, and I like to think of them as sort of the umbrella around both of them. And this would kind of be like your user experience, your UX personnel, your web developers, and other surrounding roles. These people are really what brings everything all together. And even UX is quite a big role in AI. Like all the new ChatGPT pieces of software, as you probably realize, there is a common design language to all of them. They all have their star on them, however many it is, and the colors, these are all sort of subtle things that many people don't notice. But these companies are hiring for UX specialists, web developers, back-end engineers, These are people who really bring everything all together. So in the AI space, it's not just your forefront engineers. They're still supporting kind of like glue roles that bring it all together.
That makes sense. So I guess it's like almost thinking of AI as an industry rather than a particular skill that you need to have. So all the roles that you traditionally have within the tech industry still exist within the AI space because people need to still interact with the systems. It still needs to be built and so on. Yeah, that makes so much sense. And so I guess you mentioned, or you touched on a little bit around the engineering tools people, or engineering systems, should I say? So like the Nest, the Roomba, that sort of thing, like the vacuums. What sort of industries do you tend to see MathWorks tools being used in? So, or like MATLAB and Simulink, is it generally engineering, or are there spaces outside of that that you'll see the tools being used as well?
Historically, it's always been engineering,
Mhm.
but nowadays, because AI is, everywhere, AI, software, data, we're beginning to see, the product being used by quite a lot of companies, even the Bank of England uses MATLAB, like your finance company, uses MATLAB, chemistry, it is quite broad. Historically, it's started off with maths, hence the name, the MathWorks.
Yeah.
And then it sort of got bigger to engineers, automotive, aerospace. Now it's sort of gotten a bit more broader, and there's a whole wide range of companies, using it.
So, and I guess the reason it links to AI so well is the analytics element that you can do with it quite nicely. Is that how it works? Okay.
Yeah, exactly. And one thing that we realized, a lot of our customers is that, when they build products, they want to be able to package it and sell it to customers.
Mhm.
And when they sell it to customers, the software running it is going to be running C, C++. And I can't even program C++ anymore. It's been ages I wrote C++ code. The reality is that I'm going to go in, write Python or MATLAB and just generate C++ code from it. So we're finding that a lot of customers just want to be able to take their existing design or idea and productize it from there.
Makes sense. So if somebody, so we have people that are on the call who have been learning a huge range of languages, or they're working in software engineering roles in a range of languages as well. Which language is MATLAB most like? If somebody wanted to say, let me go and have a go at that, what does it look like? Is it similar to Python? Is it similar to C, C++? What sort of things would people relate to?
Absolutely. So because it's targeted at engineers, it's very similar. It's a high level language.
Yeah.
So if you write Python, you can write MATLAB. I mean, there is a MATLAB on-ramp course, but people don't actually, in practice, you learn as you go. Just because it's so easy to pick up. The same way you pick up Python easily is the same way you just pick up MATLAB. And if I'm being honest, the language doesn't matter too much because they all have transferable skills. So once you learn Python, you really can learn another language like Rust, Go, or even MATLAB. So it's all transferable.
Fantastic. Thank you. Well, thank you, AJ. I feel like I've learned a huge amount from this session. As I mentioned, I think when we first got in contact, I used MATLAB at uni, and I just was very excited to see anything MATLAB related. So I know that people will have gained a huge amount from this session, mainly because I think it's opened up the idea that people can have roles within AI with their existing skills, and it's like a clearer path to it, and that clear path as well to understanding the sort of projects people could be doing to show that they have those skills as well. So that's been hugely beneficial for a lot of people. I'm really excited to explore. So what I've now wanted to do, and I'll talk about it afterwards, is maybe looking at a hackathon or something like that we could do that would utilize people's skills to do some engineering AI things. I don't know what it looks like yet, but I think there's a lot that we could do to help people to realize how well their skills could align to making some of these projects come to life as well. But it's been absolutely fantastic, and thank you to everyone that's been on the call, but especially thank you to you, AJ, for giving up your hour to tell us all about how people can have roles within AI and the robotics space as well. So thank you.
Oh, thanks. Thank you for having me.
Awesome. Well, enjoy the rest of your day, everybody, and I will close the call. Thank you. I'll see you all soon. Bye-bye.